Hi students, good morning to all of you and welcome in the online learning session of B.Sc Agriculture 3rd semester course Biochem 231. Students, in previous class we learned about asymmetric carbon atom and the concept of isomerism related to the asymmetric or chiral carbon atom. The isomerism, categorization of isomerism, classification of isomers like the structural and stereoisomer, then the further categorization of structural and stereoisomer and optical isomerism. D and L denomination, Van Dijk and Liebel rule. In association with previous class, today we are going to understand the actual meaning of optical isomerism and detailed study of optical isomer and the Kiliani hypothesis regarding the carbohydrate synthesis. Let us start today's session, that is the optical isomerism. Regarding the optical isomerism, optical isomers are nothing but the compound having same molecular formula, same structure, but they are differ in their spatial configuration around asymmetric carbon atom, chiral carbon atom. It indicates that the chiral carbon atom or asymmetric carbon atom is responsible for imparting the optical activity to that compound. When the aqueous solution of optically active compound, optically active substance is prepared, and when the polarized light is passed through that solution, the plane of polarized light is get deviated towards right side or towards left side, and such compounds are denominated as a dextrorotatory or levorotatory. This is the concept related to the isomerism or optical isomerism. Optical isomerism, when the path of polarized light get deviated towards the right, these are called as the dextrorotatory, and when towards the left side, then these are called as the levorotatory. Students, when the substance is responsible for the movement of plane of polarized light towards right side, then such compounds are called as dextrorotatory compound and denominated with the D or plus sign, and the compound responsible for the movement of polarized light towards the left side, then such compounds are called as levorotatory and denominated by the L or the negative sign. The concept of optical isomerism and the denomination of D or a positive sign and L indicated by negative sign is the properties related to the compound which are optically active or consisting asymmetric or chiral carbon atom. But these are not the spatial properties or spatial concern regarding the behavior or properties of the compound. The glucose, D-glucose is the dextrorotatory and D-fructose will be the levorotatory. In case of the D-erythrose is levorotatory and D-threose is dextrorotatory. Regarding this is not the exact or spatial concern regarding the exactness of the optical isomerism or optical property. For the sake of understanding and ease of reactions or indicating the properties, this is the concept indicated, that is the D for dextrorotatory, L for levorotatory. Next concept is the racimization or racimization. When the aqueous solution is containing equal concentration of dextrorotatory substance and the levorotatory substance or compound, then such solution is responsible for neutralization of both the dextrorotatory and levorotatory power, and such substances are called as the conglomerate, and hence such compounds are called as racemic mixture, and the concept is called as racimization or racimization. It is indicated by DL or positive negative sign togetherly and commonly called as the dimixture or the conglomerate. Next concept is mutarotation. The concept of mutarotation has been discovered by the scientist Dubreuil in 1846. According to Dubreuil, when the aqueous solution of carbohydrates are prepared, that is optically active compounds, when the solution is prepared, aqueous solution is prepared, the specific rotatory power of the substance or carbohydrate is at initial stage is more, and then after it is gradually decreased to a constant value or gradually changes to a constant value. Such constant value is actually called as the mutarotation. The mutarotation in scientific way means the gradual change in the specific rotatory power of carbohydrate to a constant value is called as mutarotation. Mutarotation is also called as the birotation or multirotation. When the aqueous solution of alpha D glucose is prepared, then the at initial condition specific rotatory power of alpha D glucose is about 112.2 degree, and when the solution is allowed to stand for some time, then after the specific rotatory power is gradually changes to 52.7 degree and it remains constant at this value. This value is called as the mutarotation, birotation, multirotation. In case of beta D glucose at initial condition, the specific rotatory power, optical rotatory power is about 18.7 degree, and then after it increased to the gradual changes carried out when the solution is kept for some time. Then after the optical rotatory power increased from 18.7 degree to 52.7 degree, and it remains constant at the 52.7 degree. This is called as the mutarotatory power of the alpha D glucose or beta D glucose. The reaction or the property is indicated in front of you on the blackboard. This is the information about mutarotation. It is also called as the birotation or multirotation. Next most important concept is Kiliani hypothesis. The method of monosaccharide synthesis was proposed by Kiliani in 1886, and after the completion of reaction, there is a synthesis of two tetroses. These are the D-erythrose and D-threose. The complete reaction is carried out in four segments. First part of reaction is the cyanohydrin formation. Second part of this reaction is hydrolysis. Third one lactonization, and fourth one reduction. And after the complete reduction of the glyceraldehyde, then there is a synthesis of two tetroses containing 4 carbon atoms. These are D-erythrose and D-threose. The complete reaction is in front of you. When the hydrocyanic acid is treated with the glyceraldehyde, then there is a synthesis of two compounds. These compounds are in front of you. These are the compounds are cyanohydrin. There is a cyanohydrin formation. So here after the cyanohydrin formation, next reaction, that is the hydrolysis. After the complete hydrolysis of the cyanohydrin, then there is the synthesis of the carboxylic acid. Then after the lactonization, the compounds are formed. These compounds are then after converted into the tetroses containing 4 carbon atoms, that is the D-erythrose and D3. When the reaction is repeated, then after there is a synthesis of the pentoses, and then after the hexoses from the pentoses. The complete reaction regarding the Kiliani hypothesis or the second part of Kiliani hypothesis is in front of you. According to the second part of Kiliani hypothesis, when the D-erythrose and D-threose are formed, then after these D-erythrose and D-threose are responsible for synthesis of again 4 different compounds. Then after these compounds are responsible for synthesis of 6 carbon atom compounds, and the denomination of these compounds are in front of you. The second part of Kiliani hypothesis, the complete reactions are in front of you. According to the second part of Kiliani hypothesis, when the reactions are repeated, then after the two tetroses, these are the D-erythrose and D-threose are formed after complete reduction of lactones. When the D-erythrose and D-threose are formed, these are responsible for the further formation of 5 carbon atom compound. These are ribose and arabinose from the D-erythrose, and regarding the D-threose, 2 compounds are synthesized. These are named as a xylose and lysose. The configuration is in front of you. Ribose is responsible for synthesis of 6 carbon atom compounds. These are the allose and altrose, and from the arabinose 2 compounds, these are the glucose and mannose are synthesized. These are 6 carbon atom compound. From the xylose 2 6 carbon atom compounds are synthesized. These are named as the D-glucose and D-iodose, and then after from the compound the lysose 2 6 carbon atom compounds are synthesized. These are the D-galactose and D-talose. The complete reaction is in front of you. This is called as the Kiliani hypothesis of monosaccharide synthesis or Kiliani hypothesis of carbohydrate synthesis. This is the second part of Kiliani hypothesis. Thank you for watching this video. If you are benefited by this video, like this video, subscribe my YouTube channel and follow me on Facebook, Instagram and WhatsApp. If you are facing any difficulty, personally you can contact on contact number 9421872858 and you can mail your difficulty or you can post your difficulty on your Google Classroom page. And my email ID for further communication is atulebondwe@gmail.com.